Good afternoon, everyone. Thank you for coming today. It really means a lot to me. And thank you, Nikita and SSERD team, for having me here today, for giving this opportunity to share my passion about space and robotics with people from diverse backgrounds and diverse interests. And so I'll give a brief background about myself. But before that, I would say, like, you guys are like really lucky generation because you can have what you dream. For example, you have like SSERD and organizations like this where you can go to and learn more about space while you are growing up. When we were students, and even in my bachelor's, I had no one to guide me, although I was like very passionate about space, aerospace and astronomy. But I just like tried to find a path by myself, and now like I know a lot of people who are like me and had a similar path like me, and they are trying to make it better for the next generation. So try to use this opportunity and go to the organizations and NGOs like this and be a part of it so that you can learn more. And it doesn't matter what you do when you grow up, but just learn more as you are growing. And if you cannot hear me properly, if you cannot see the slides, just let me know because I have a bit of cold, so just let me know. You can stop me and let me know that. So welcome, everyone. A bit about my background. I did my bachelor's in electrical and electronics engineering at NIT Jamshedpur. Some of my batchmates are here. Thank you for coming. Then I did my master's in space studies at International Space University in Strasbourg in France. And after that, for a couple of years, I was like a research scholar in Skolkovo Institute of Science and Technology in Moscow in Russia. And the department was Space and Engineering Systems. And since 2018, I'm doing my PhD in space robotics in Aerospace Engineering Department of Tohoku University in Japan. So my talk would be a bit general to cater to the diverse audience over here. So it's about robots and their applications. What does intelligent robots mean, and what is smart computing? What is the history of robotic exploration in space, robotics in space exploration? The rationale and role of robotics in future space exploration, and how you can stay in loop with the changing scenario, because the technology and the technology is changing rapidly, so you have to be updated. And then at the end, I'll show you an interesting video of an analog mission. So what are robots? Can you tell me, like the first row? What are robots? Artificial intelligence, yes.
Robots are machines which work somewhere or somewhere in space.
Okay. Yes?
Robots are machines which can perform what we desire.
What we desire. Very close. So robot is a machine, yes, especially one that can be programmed and that is capable of carrying out complex series of actions, as you said, that we desire automatically or by an external guidance or control device. So this term was coined by a Czech Republic writer called Karel Čapek, and robota in Czech means forced labor. So you can see like carrying out complex series that we desire. And the robot family is really big. So as you can see, like some robots look like humans, uncannily like humans, some not so like humans. And people like to make many different kind of robots for different purposes. Like also bio-inspired robots, which look like spiders or ladybird bug, or like flies, dogs, and things like that. So these different kind of designs of robots have different applications. For example, these snake-like robots, they can be used for cleaning pipelines or water pipes, and those things that are accessible to these kinds of robots. Then there are like assistive and collaborative robots, which are basically used in industry or factories, and also like exoskeletons. Like for example, if there are like handicapped people or disabled people, they can use robots as an exoskeleton that can be like the helping or assistive body parts for them. As well as drones are also collaborative. Yes?
I saw that drone in one marriage.
Oh yeah, yes. Nowadays it's a very commercial application of drones to film weddings. Yes. And of course, swarm of robots, which are a very novel application of robots. So a team of robots working together to accomplish a common goal. And these types of robots can be like homogeneous or heterogeneous, meaning like they can all be of the same type, or they can be of different types working together to achieve a common goal. And they can also be like centralized or decentralized. So centralized in the sense they can have a master and lots of robots can work as slaves, or they can be decentralized, like each of the rovers or robots can have their own independent control. So as you can see, like robots come in different shapes and sizes. The question then comes, why do we need robots? Why do we need robots? You said like they can do some tasks that we desire them to do, right? So that's one thing, but also robots can perform repetitive and dangerous tasks, which humans can do. Maybe they cannot do it, or there are limitations of humans because of size. So we make robots, and robots can work in very extreme environments like outer space, in the bottom of the sea. When there's a disaster, robots can work and rescue people. Then there are war sites, so robots can survey, and so like there are many different applications where robots are employed. It's not so evident in India, but in Japan, where I'm studying, there are robots like everywhere. Like they are in the restaurant, they are in homes. People have pet robots, and then they are of course in the labs, and yeah, like they are doing maintenance and inspection of pipelines, power lines, nuclear power plants, and things like that. So there are many different applications where robots can be used. So how can we make these robots intelligent? How can the systems operate intelligently? Do you know how you can do it? Do you have some ideas how a system or a machine can become intelligent? Humans are intelligent, right? How can we make systems that we are creating as intelligent as us? Any ideas? Sorry? Yeah, by making them learn. So first thing, before they start learning, they have to sense their environment, right? So basically, you have to make them more like living beings. That is, give them a brain and a nervous system. So you have to make these machines see, touch, hear, move around, feel the environment, and give feedback to from that environment, which is called like stimuli. So that's how you can, like, as you can see in this picture, like a simple robot dog, it has like so many sensors and control systems so that it can feel and touch and smell and things just like an exact dog would do. And of course, maybe you have heard about all the heavy terms like artificial intelligence, neural networks, Internet of Things, cloud computing, machine learning, big data, and stuff like that. So all of these come together as smart computing, and these help the robots to work as an intelligent system. So what's smart computing? Smart computing is a generation of hardware, software, and a lot of networks of sensors that can create like an infrastructure with analytic computing systems. So I'll explain it in more details with an example. It's basically how you can mimic a newborn. So when a child is born, it starts observing the environment and slowly starts to understand and learn the situation. and and it saves those situations in his or her own mind. So when in future something like that happens, he or she can react in a very specific way. So that's like learning. So that's what we also do with robots. So I'm a bit sorry about this video, it's a bit dark, but here I'm like training my robot to identify the different obstacles, as well as, so there are like 3 robots over here, and each of the robots, they can identify each other. And the moment they identify each other, they are given rewards for identifying each other. So just like you train a dog, you give a bone or a chocolate or some toy when they fetch and bring. That's what we do with robots as well. We train them. And so every time they identify an obstacle or identify another rover, then we give them a kind of reward, which is in terms of point or lifetime to the robot. And that's how they learn to understand the environment. They map the environment. So this is like, it's doing autonomous mapping. And so autonomous mapping is through the different sensors. Again, it has a camera, it has a LiDAR. So it's mapping the environment, which is called simultaneous localization and mapping. So it autonomously, simultaneously maps the environment, and then it takes decisions and where to go and how to go. So that's called like path planning, which is a very complex subject of robotics itself. And then we come to robotics and space exploration. So again, why do we need robots in space exploration? We go back to the same thing that I said earlier, because extreme environment. Space is really harsh. There is microgravity, there's like space radiation, extreme temperatures, these things are like very dangerous and harmful for humans. Yes?
It's like a solar light.
What's a solar light?
Not solar light, like that.
Satellite. Okay, so satellites are also robots. Those are like robotic spacecrafts in space, and they have some specific purposes. So they are out of Earth, they are in the orbit, and they are observing what's happening on Earth. They are observing the oceans, they're observing the traffic, like you use Google Maps, right? So it's from the satellites. The satellites are observing where you have like a lot of traffic, or the satellite is mapping the place. So it's also a kind of robot, and they are also controlled by stations here on Earth. Like ISRO has their ground stations, and a lot of other universities have their ground stations. So yeah, that's what a satellite is. Good question. Thank you. And so that's why we use robots. Humans cannot, we need a lot of satellites or a lot of robots to do those tasks, and we cannot have so many humans up there to do that. So that's why we need robots, and that makes it cost effective. So having robots up there with like multiple sensors, it drastically reduces the cost as compared to having humans, which if there are humans, that increases the cost, it increases the risk. And like the location or the environment is not feasible for humans. So lots of difficulties to have humans over there. So what can robots do in space? Robots can do everything in space that they can do here on Earth. So they can do exploration and surveying. Like satellites are examples of that. They are up there in the orbit, and they are exploring over there. Then there's lots of, for example, this is a rover. This is a mock-up of a rover, and this is also like built for surveying and exploration of the moon surface, of the lunar surface. So it can have like cameras and sensors over there, and it can move around on the surface of the moon and collect samples and do some analysis. Robots can also do assembly and construction. Maybe you have heard about 3D printing. So you can also have a look over here. They have a 3D printer. So having robots that can do construction or building up houses as in a 3D printer. So if we go to moon and or Mars, and when we build up habitats or houses over there for humans, that's when we will need like huge 3D printing robotic robots that can help in construction of these houses. Servicing and maintenance. Robots can help in servicing and maintenance, just like they help here in in automation and car industry. They kind of do servicing and maintenance. Similarly, robots can help in space as well. Yes?
Like a transformer?
Not like a transformer. No. So it's mostly for like a robotic arm. So you have the robots doing some servicing and opening the nuts and bolts of different machines. So that's called servicing. And robotic landings. I'm not sure if you have seen some of the very cool SpaceX videos. So if you have seen this, like SpaceX has controlled landing of its booster. So very beautifully, these boosters come back from the space and like land. So these are actually robotic and controlled. So also in space, when we have our habitats in moon would be like a relay surface from where we can launch and go to other farther planets. So that's where robotic landings would come in use. Yes, you had a question?
Is it just like in the news they launched the rocket?
Yes. Yes. Some of the very famous space robots are like Lunokhod rover. It was built by the United Soviet, so USSR, in 1970, and there were like 7 Lunokhod rovers that were launched on the moon between 1969 to 1977, and those were like these but bigger size, like from ground to here, quite big. And they would go around traveling on the surface of moon, collecting samples and sending pictures. Also, there's Voyager. Voyager was built by NASA, Voyager 1 and Voyager 2, and they were launched in 1977. And it was to explore the outer solar system. So, like, I wouldn't say these robots were intelligent, but they were very diligent, because they still, like Voyager 1 and Voyager 2, they still send data. They are like billions of light years away from Earth into the interstellar medium, and they're still sending data. And there are people in NASA who are like still maintaining these spacecrafts. Some few more like modern robots in space are Canadarm. So it was built by the Canadian Space Agency, and it's installed in the International Space Station. So the work of this robotic arm is to capture, like, International Space Agency has astronauts living over there. So as we speak, there are 3 astronauts up there in the International Space Station, and they are living over there. So we need to send them food, clothes, and they have their waste. So we have to bring back those waste and stuff. So they, like NASA and the Russian Space Agency and SpaceX, they launch some supply modules, and this robotic arm tries to capture this module when the module is close to the space station. So that's a very important use of robotics over here. Then there's very famous Curiosity, which is right now in on Mars. It was launched 7.5 Earth years ago, and it's still like moving around on the surface of Mars and collecting data and doing a lot of discoveries. Like it discovered that there are like water riles on the surface of Mars, which means like there used to be some water in Mars earlier, so lots of like very useful discoveries. Then there's Hayabusa landers. So my lab was working on these landers. So these are like small round landers, and they were dropped on asteroid Ryugu. So do you know what's an asteroid is? So asteroids are like rocky celestial bodies which are between Mars and Jupiter. So there's an asteroid belt, and these asteroids are like thought to have some organic compounds or some useful minerals that are very like expensive. So humans wants to go and explore these asteroids. So Japan decided like they would be like dropping rovers on these asteroid robots and see what's on the surface of this asteroid. And there are like a lot of future robotic missions which are planned to happen in the next few years. This is, yeah, it's again a bit dark. So it's for on-orbiting service and assembly. So we have a lot of satellites up there in the orbit outside Earth, right? But those satellites are not like forever. They cannot live forever. They have a lifetime, like 1 year to 5 years or 10 years. So, but after that, they become junk, like kachra and like waste. So we have to do some servicing with these satellites. And how can we do that? So like robotics and people like scientists and NASA, they are trying to build new satellites that can work as a servicing module for old satellites. So this satellite goes up there, and then with its robotic arm, it refills the old satellite or does some fixing and servicing. So that's like a future mission which would happen very soon. Then there's Mars helicopter. We know, like, you have seen drones around here on Earth, but in Mars, the atmosphere of Mars is very thin. So it's very difficult to fly something. It's possible to make stuff move on the surface, but flying something, it's a very difficult thing. But NASA, they are launching a helicopter to study like if it's possible to have a drone hopping on the surface of Mars. And then there's telescope. Telescopes are also, like space telescopes are also robotic, because like they are up there in space, and then they open up and observe and move around the lens and the observing observing material to observe what they are asked to observe. Yeah, sure.
I have a telescope.
Yeah. Do you watch the stars?
Huh?
Do you watch the stars every day?
Never use a telescope.
Oh. You should go to the space camps with SSERD to watch the stars. And there are many different designs of robots that are being planned to be launched very soon. So do you know what an origami is? Origami is, do you know?
It's a kind of paper sheet and you make something.
Yes, yes. So like you have a piece of paper, and you fold and you make like cranes or birds, or you can make different kind of patterns. So like you basically fold and make different structures. So there are robots inspired by origami. So these robots, they can change shapes, just like you can like fold and open up and change shapes. So again, like NASA Jet Propulsion Laboratory, they are developing this kind of robots, and I was like, I worked on this for a week and it's really cool. And like it's this small, but it has some sensors which makes it learn the environment and makes it do what we program it to do. So it's really cool. And then there are rock climbing robots. So robots which have like grippers or claws, just like say like an animal which can climb up the rock. So, and this is a very powerful robot because it can predict how and where it has to put the next step. So you can imagine like when we launch it to moon and there is a cave or a crater which is like very deep, and we cannot see it like through a satellite or with a camera, but this robot can decide itself and make the decision where to move, where to put its next step. Also, like my personal favorites are like sorry. I don't know why it's done. Okay. Yeah. It has moved. Okay. Okay, sorry about that. So icy moons are, you know, Jupiter and Saturn, they have many satellites. Like Earth has the moon, Jupiter and Saturn has many natural satellites. So these satellites are believed to have like a lot of organic compounds or compounds that can support life. And some of these satellites are like Europa, which is a natural satellite of Jupiter, and then there is Enceladus, which is a natural satellite of Saturn. So these satellites, by the past missions, it has been observed that these icy moons, these are called icy moons because on the surface they have ice, and below the surface there are like oceans. These are called subsurface oceans, and these oceans might have organic compounds which can give lead to having life, just like it started on Earth like billions of years ago. And for that they are developing like robots. So these robots can go into the ice and then explore under this ice layer and explore the water over there and send data to the scientists. So the question comes now, like we saw like robots are very useful, robots can do a lot of tasks. So should we have robots or astronauts? Like, you know that the Indian Space Research Organization, if you have followed the news lately, they made a robot, a humanoid, that they are planning to send to space before they send humans. So it's basically because it's safer to send a humanoid robot than sending a human. And similarly, NASA also has similar robots which are like astronauts, but they are robots. So the question is like, do we have robots or astronauts? What do we have? Should we send humans to space or should we have just robots? What do you think? Sorry? Robots, yeah?
Robot or astronaut? Some robots do not know some things.
I like that.
Should we clap?
Exactly. Yes. Exactly. Robots can do a lot of tasks, but still humans are still superior. And even for space exploration, we should have both robots and astronauts, and they can cooperate together and work. So it is like a lot of studies are going on to see what is the best way to control these robots and how to have the best out of space exploration by having human and robots cooperation. So there can be like, we can send humans to the orbit and have robots on the surface of Moon or Mars, and these humans can control the robots from the orbit, from the space station. That's one way where you have like cooperation. Then there's also, I don't know if you have watched this movie called Big Hero 6. It's a Disney animated movie. If you haven't watch it. Have you watched it?
Yeah.
Yes. So yes, definitely everyone should watch it. It's a very cool movie about robots, and in that this kid, he makes different kind of robots, and he has a team of robots which he can control by his mind. So that's a way by which you can control robots. There's a lot of studies going on in that. So you can control robots by your mind, by just like there can be a device which can read your neuron. Yes?
Is it like Cosmo?
What's Cosmo?
Cosmo is one kind of robot.
I am not sure about Cosmo. I'll check it. Yeah. So similarly, there are also gloves where you can, if there are some very cool videos on YouTube where they are like, they have a glove and then they control many drones by their gloves. So that's one way where astronauts can control robots and can be used for space exploration. So these are like different kinds of interaction. It's a different field of study called human-robot interaction. And it's very interesting, especially in terms of space exploration, because of course humans, we want to go to space and we have to take the robots with us. So there are like some space robotics projects that I have worked on. When I was in Skoltech in Russia, I worked on like drones, and these drones were able to, I programmed them in a way that they were able to localize and navigate themselves in a building like this. Like if you are inside a building and there are lots of other buildings around you, your GPS signals are very weak. So that's when, and robots usually which you see outside, they use GPS signals to move around, just like when you are on a car and you want to navigate, you use GPS, right? Drones also use GPS, but where the GPS signals are low, that's when the problem arises. And so we use, again, a lot of sensors like vision sensors, like cameras and infrared sensors. And by these kind of sensors, the drones can sense its environment and it can understand where it has to stop and where it has to move around. So that was my work in Moscow, and currently I'm working on multi-rover systems or swarm robotics. So I'm doing the path planning of swarm robotics, and in this robotics, like these rovers, the rovers are of this size, and they have like camera and a LiDAR and and also like radio communication modules. So they communicate with each other. So basically, if you imagine a group of friends, you are going somewhere together, but some of them, due to miscommunication, they go away somewhere else. So that's not like coordination, right? And I want my robots to have coordination. So I'm working on the communication part of these robots so that they can exchange messages with each other, and they know where they are, and accordingly they can plan. Like for example, you have like 5 friends and you're going to watch a movie, and like suddenly someone just went somewhere else, and then you communicate with each other and you say like, oh, okay, we will not go to that movie, we'll rather go to another place. So that's how you plan it. So that's exactly what I want to do with the rovers. So this was basically about space robots, and why it matters, because space robotics is a very big market right now, and in the next 4 years, it's going to become like $3 billion US dollars. And it's a big, big market. So you can imagine like, and actually Asia Pacific region, like China, India, Japan, these places, it's a big market right now. And people are investing a lot on space robotics. So it's a very interesting topic as well as it brings money, so both are good. So what do you need to learn and what you should know to stay updated with this field? So you should, like, from the very beginning, you should develop logic thinking and systems thinking. And like, just like you want the robots to solve a problem or solve a situation, you should think that way. Like, what would I do if I was in this situation? And program the robot just like that. So, and of course, programming languages are important for that. Currently, Python and C++ are very useful, but these programming languages, they keep changing. So maybe in 5 years, there will be a new programming language which is more user-friendly. But definitely, the logic of all the programming languages are the same. And a robotic operating system, if you want to start with robotics programming, definitely check out robotics operating system, which is an open source system or openware, where you can like visually simulate different kind of rovers and robots by just simple programming. And of course, persistence. Like, persistence is very important when you are.
Can you install any of the Windows machines?
Not Windows, actually. It works only on Linux. But there is also a Windows version of robotics operating system. There are like tutorials on YouTube, which you can just search. And there is like, you can install a platform on your Windows that can support robotic operating system. Yes?
How about a phone? Like, a phone will control the robot.
Yeah, phones can also control robot. You can make an application, and also you can do that in robotic operating system. You can make an application for your robot, and you can just control it with your phone. And there are many universities in India and abroad that give like robotics and mechatronics courses. Some of these are like Triple IT Hyderabad, Triple IT Allahabad, IIT Kanpur, IIT Bombay, Amity University. In Japan, of course, Tokyo University, Tohoku University. So in Japan, robotics is like the course to be in, because it's not just space robotics course. They have different courses for different kind of applications of robots. So there are smart robots, there are space robots, there are rescue and disaster robots, so all different courses. So it's pretty interesting. Also in US, they have very good laboratories for space robotics and space robotics. And there are many companies, both in India and abroad, where you can work as a roboticist. So it's pretty cool. And that's all from me about the space robotics. If you have any questions, I will take it very soon. But I would like to show you a short video about so I was supposed to go to US right now, but due to some visa issues, I couldn't go there. But my team is over there. They are doing an analog mission. So analog mission is like, just like a place on Earth, which is a mimic of Mars. So this place is similar to Mars environment. They have the geology and the astrobiological characteristics of this place is just like it is in Mars. So they do a lot of analog missions. So teams of scientists go there and do some research. And like my team is over there right now. And I would like to show you a video about it. So it's called Mars Desert Research Station. It looks very much like Mars, right? It's red and they have this habitat. So they wear suits and go out and collect samples, just like you would do on Mars. They also collect soil from outside and then they bring those and grow crops. That's our mission patch. It's called Earth to Mars.
So where physically located?
It's in Utah, in US. It's in the desert.
So how many acres of the land?
Sorry?
How many acres of the land they?
I don't know. It's basically in the middle of the desert. So yeah, that's it from me. Thank you so much. And this is a Japanese robot. Its name is Now. It's pretty cool. So yeah.
Why is the top thing black? Is it a star or is it space? I think it's space. I don't see any stars.
So because these, which one? This one? So all these pictures are taken during the day. So yeah, but also because it's in the desert, the skies are like very beautiful. And yes, I will tell my team to send pictures of the sky, and because they can see the Milky Way from there. Yeah. So if you have any questions, I'm happy to take those questions. Sorry? Data science. So data science is a lot of like big data. So that can be used for training. So the more data you have, you can train your system in a better way. So yeah, data science is pretty useful. Yeah, IT, data science, computer science, mechanical, electronics, automation, all of these disciplines are useful for robotics.